seat is, yeah, this seat is missing.
Right, before we start, any news, any announcements, anything fun?
I ate so much.
You ate so much, all right. But I said anything fun.
I cooked so much.
Yeah, and then. Who else
Went home.
went home? Good. Anyone attempted tandoori turkey?
To do what?
I cooked it, not this year, a couple of years ago, I cooked a tandoori turkey.
Tandoori turkey.
Oh, it was
sorry, I'm saying it wrong. I should say it your way.
More importantly, it was the first time in my life, there was no turkey left at the end of the day.
Oh, wow.
Hey.
That's pretty cool.
Anything else?
Where did you get a tandoori?
You get the paste. Oh, that's a good thing. What you do is the back of the turkey came in and clean it out. Made the marinade. Then put the turkey in and seal the bag back up and kept full of fridge overnight.
I'm asking where you got the oven.
Oh, not normal oven.
Oh, a normal one, not a
You don't need a
tandoori.
tandoor. Yeah, I mean, if you have a tandoor, it's even better. What else? Any other news? I have a bit of news. So email thing happened, what, 10 days ago? Or 2 weeks ago? Among other things, Sihan had a paper, and I don't know what the exact meaning of this was, but the program committee selected some 30 papers out of 1800 to highlight in the opening presentation. And Sihan's was one of them, so I guess congratulations to you. And I calculated it's about 2% of the paper. And he actually got a letter from them, some certificate. So Sihan, in absentia, we clap for you. Any other news? Any other big tidings? Yes.
So I bought some popcorn from Chicago.
Oh,
And all the popcorn is Chicago made. I put it over there.
Is it special popcorn?
It's called Chicago made. It's caramel and cheese.
Oh,
So
you're
supposed to eat them together.
All right, good. So Chicago popcorn to share. Thanks, Jan.
Sounds wonderfully disgusting.
Oh, next semester, we're gonna figure out, so Shiloh and Yulu have started internal discussion how to do seminars next semester. Because they'll be split, some people will be up in Mount Washington, some people will be here. So we'll figure it out. I think the thinking is that initially they'll all be here because the Mount Washington facility may or may not be ready. But there is gonna be a one room over there where we can have seminars, and if you can book it, then we'll alternate. For the external speakers, what we'll do is we'll typically go by where the faculty host is, because half the faculty are gonna stay back here. So if the faculty host is here, the seminar will be here. This is what we are thinking. We'll see how it goes. The student seminars, on the other hand, is a bit of a dilemma. Because I have a feeling that if it's gonna be, there's gonna be food, it'll have to be here because that's where we have food. So over there, Karen and Myra are not moving, so they'll still be there. Other than that, I don't know. You guys have opinions about where to have the student seminar? There's Shiloh and Yulu, and they'll bring your opinions to the meeting. Anything else? And you're having a poster session.
My machine preparation class.
Yeah.
That's minor project, but that's gonna be a full session.
Tuesday, Thursday, 1:30?
Thursday, 1:30.
Where?
Second floor.
That idea from Danielle. He's doing that place.
Second floor?
Second floor.
Ackerman, second floor, Tuesday, Thursday, 1:30.
Yeah, so that's 2 sessions, about 20 plus courses.
Yeah.
Out of curiosity, if you want to have an event on the second floor of Ackerman, how do you find out that nobody else is trying to do it at the same time?
I asked Daniel about it, they just tell Karen and what happened. I don't think that the end.
It's just scary. It's not a reservable space.
It is in the evenings.
Is it? Oh,
During the day, it's supposed to be.
it's on 25 Live. The
Okay.
hallway. The hallway is on 25 Live.
No. But in the evenings, if you're gonna have something, you tell some events, people.
Oh, I see.
I don't know if they reserve anything, but they just make a note, especially if you want to bring in stuff, like easels, tables. So when Joanne does her hackathon, this is Joanne Solinsky. We usually have this. All right.
On a similar note, next Friday evening, my class is having a tournament for Wheel of Fortune. If you know the game, they all have to play, build bots to play Wheel of Fortune, and they're gonna have a tournament. So if you wanna come play against their bots, you're gonna do that. That's gonna be the Bloomberg site, the new Bloomberg Center next Friday evening.
Actually, but this is what's the game again?
Wheel of Fortune is a TV game show.
Down in white.
Oh, is that one where you buy vowels?
Yeah,
Okay.
Yeah.
so some of them projects, they had to decide whether or not you should buy vowels.
Yeah. You know the story, right? Eastern Europe, they were very poor. Because they don't have a lot of vowels.
And Scrabble bells are quite cheap.
Right? You gonna say?
I said, as a Scrabble player, I always thought vowels were the cheapest.
Except why?
Right. That's true.
All right. Enough joking. I think we should give these ladies and gentlemen a chance to tell us about what they want to tell about. All right, guys, all yours.
Cool. Yeah, thank you everyone for coming today. The talk is about LLM coding agents. And this was a topic that was suggested. I don't know how it was suggested, but we came up with a panel that will talk about their experiences. And I guess you can start off with everyone introducing themselves and some background information and how long you've been using coding agents.
Sure. I'm Nathan Breslow. I am a sophomore undergraduate. I've been using like LLMs for coding like since ChatGPT came out, GitHub Copilot probably before that, and I tried that back in like 2019, an experimental LSTM for tab code completion. So I've been with it a while and I've gotten to see the field evolve.
Hi, I'm Prabhav. I'm a second year master's student. I am actually been a late adopter of this stuff. So I worked in the industry for 2 years before starting my master's. And for the entire 2 years, I did not use any assistance for coding. And since I've started my master's, I've started using them more and more. And so I think I have a perspective from both sides that I'm hoping I'll share here.
I'm Tianjian. I'm a second year PhD student. I think I'm relatively new to coding assistance because I think I've just started using it at the beginning of this year, I would say. And I don't think I'm trying to use the very advanced sort of coding assistant, only like the very sort of basic ones. So yeah, I think I'm least experienced in terms of using these like agents.
Introduce yourself.
Also, yeah, my name is Sadam Samuel. I'm a first year PhD student and I don't have experience using coding agents. So I think my perspective coming into this panel is to ask some, well, I wouldn't say hard questions, but maybe interrogate you guys a little bit and see if I can be convinced. And maybe some other people in the audience can either be convinced or not convinced to use them. And okay, so to start, I want to hear about, and we'll also have an opportunity for everyone to also ask questions too, but we'll start off with some setup questions. But which coding agents do you prefer? And whoever has like a short demo, whoever has a verbal demo, like explanation can go first, and then if you have an actual demo.
All right, I'll go first verbally. My preferred coding agent tends to be a terminal GUI and generally Claude Code or Codex, which Codex is basically OpenAI's version of Claude Code. And what they consist of is, as you're about to see, you essentially have a text interface where you communicate with the AI model, and then the AI model can take actions on your computer, edit files, run files, and will report back to you. And it's very much like you're texting in sort of a chat with the AI model. And it's somewhere in between a command-line interface and a more traditional GUI.
Yeah, so I think I can also share.
When you say a terminal GUI, do you mean one that's specialized for that, or you mean you open up a terminal?
You open up a terminal, but the terminal is sort of commandeered to look as if it was a traditional graphical user interface. It's better to see.
Maybe I can show it.
He can show you.
Okay, so this is some folder I have some code in, and all you basically do is on your terminal, you go with this. So you can resume your previous chats too. This is what I'm doing right now. And it opens up a window that looks something like this. You have this window over here where you can chat with the assistant. You can insert your queries. I specifically use Claude Code. I like the interface a lot. It gives you a lot of options and a lot of customization, which I tend to use. The best thing that I like about terminal agents is that you can give them access to the files and folders that you want and not everything else. With UI, like if you use Claude on a web browser, you need to upload your files to the web browser and then ask more queries and then upload more files. With this, I can just mention a path and it gets access to all the files in the path. So that's easy to control. It has some modes. So if you see that except edits on in the bottom, that means that the Claude Code agent can make whatever edits it wants. You can put it in plan mode, in which case it decides what to do but doesn't execute before your explicit command. And then there's some shortcuts for making more agents. I don't usually use these, but they're like some really advanced shortcuts in here. And you just basically ask a question.
Not sure how useful all the advanced commands
What
are.
you're running here is Claude Code,
Claude Code.
and it's an application that
You-
you start in your terminal.
Yes.
Yeah.
Yes, you install it like with NPM.
And you can it connects to your account, and I think it's like $20 a month, and you get pretty much unlimited access. I mean, I've never run out of it. So
You will often see people on Reddit complaining that they ran out of access to Claude Code. That's normally because they're like dumping hundreds of thousands of tokens worth of content into it. If you use it responsibly, you will not run out of
Yeah.
access on the $20 a month plan.
And I think the best thing about using a terminal agent is context management. So I'm not sure if people have gone through this, but there's a really nice blog from Anthropic. It's this one, Effective Context Engineering for AI Agents. They have a really cool method of folding the context into the agent in every few steps that allows you to basically have infinite context window over here. So every few steps, what it does in the background is it takes all the documents and all the chat that it has done and folds it into a smaller compressed memory so that it can keep continuing to have the same chat in the same window permanently, and it never runs out of this context window.
It's called compaction, I think.
Yeah, compaction.
And
That's pretty useful.
if you don't mind me jumping in,
Yeah.
compaction is becoming a lot more popular. OpenAI's new model, GPT-5 Codex Max, OpenAI is very bad at naming things, is trained with end-to-end RL using compaction. So it's in training, is trained to operate after having compacted a context already. So this kind of has gone from less of a hack that they use to get around context windows to more of like an actual principle of how a long-running agent does things.
I'm sorry, my internet is not working over here, the Hopkins Wi-Fi, so it's not working, but
You can't actually see what's being sent to the LM, right? Like it's compacted, but you can't see what it is.
Depends on what you mean. As in with Codex, it's open source. So if you wanted to, you could go in and modify.
You could dump it out.
You could dump it out. Claude Code is not open source, unfortunately. I'm not sure if there's an option to see what's being compacted, but
you can see this. So this is what you get to see. You get to see what amount of tokens are going to the model, what amount of tokens are being compacted, what amounts of tokens, or how many tokens do you have free left. This is the kind of view that it gives you. It has a 200K context window in general. So you can see like how much of it is being used by a system, drawn by our tools, and so on and so forth. That's the amount that I get, at least.
yeah. Do you use any MCP tools?
No.
Yeah, no, I don't use any either. I don't want
Yeah.
to be on here.
Okay, maybe I can share something. I don't use Claude Code. What I use is called GitHub Copilot, which is I think I've used it a lot. Share the screen. So this Copilot thing has this is the interface of VS Code, and here you have this Copilot right here. Let's see, Ask Copilot. And here there's three modes. If you scroll down the tab right here, I don't know if everyone's gonna see it. Here there's three modes: ask, edit, and agent. So what the ask does is that you can ask like natural language questions to it. For example, I have some code right here, and I will just ask the model. You can actually choose which model you want to use right here. But here I'm using Cloud Sonnet 4.5. You can actually choose whichever API model you want to use right here. And if I just explain what the code does, the Copilot just runs, reads this line, and actually, dispatch rate automates the evaluation to modify AI models. This is something that I just wrote this morning about evaluating models on specific data. So this is what the ask does. If you go to edit, you can actually edit some of the contents in the file. So for example, if I can write something like if I want to change this max tokens, right? you can say just change max tokens to 16K. Let's see if it works. I don't know if it works, but hopefully it does. So I think it's really fast. So you can see that this immediately gives you a change. The red line is the thing that's deleted. The green line is the thing that's edited. This is a very simple case, but it also can operate very complex cases as well. And you can actually choose to keep or undo this. So you can actually see where the content is changing. Right here you can see the two out of two of this changing, and you can actually to keep either of them, or you can actually do this, right? It's very customizable. You can actually choose whichever changes you want to approve, whichever changes you don't you think it's not right. So you have like full control over the file. This is what the edit mode does, and this is actually what I use the most because I can see what's actually being changed, and I can actually choose to accept or not. Something that also people have been using is this agent mode. Is that if you want to create a file that is something, or if you want to like run it actually runs the code for you, or you can actually create new files, write new code. This mode, I think they also give you the option to accept or not accept the change, but it's not as transparent as the edit mode. So the edit mode is that what I use most. I always enter natural language instructions. For example, write a certain feature for me. Help me debug this code. What is wrong with this code? I always enter these kind of instructions and use the edit mode the most. I'm a bit afraid to use the agent mode because I'm always afraid of it like messing up with my code. So yeah, this is I think I'm not.
Although it's in GitHub, right? So if it does mess up, you can revert.
Yeah, you can always revert if it messes up. But I think it has access to also the directory, so we can actually remove some of the files as well. And I don't know how it messes up with that, so I'm a little bit afraid, but I think it's pretty safe. I think
But it won't rewrite Git history, I imagine.
I don't
No,
think
it doesn't have, like, when you start the agent in a directory, you can specify which files you want it to have
What
access to.
permissions it has,
Yeah.
but I typically can't mess with anything outside of the directory, except when I run it in the YOLO mode.
Yeah. Something I want to add right here is that you can actually add context right here. So if you want to add more context to the instructions, you can actually choose whichever files the agent wants to see. This is very useful if you're like debugging a training run where you have the model file, or you also have the example optimizer file you want to debug something. This is particularly useful if you really know whichever file is used in this context. Yeah, this is just my experience with using this, and this is actually what I use pretty much every day.
Yeah, an alternative is if you're using like an agent from the terminal, you can just say, look at this in this file and understand how it works, and the agent will observe all the function names in the file and go through your code base and track down where they come from, so you don't have to manually insert the necessary files. Typical frontier models tend to be smart enough to do that. I wouldn't have trusted them to do it a year ago, but these days they're pretty good at it.
Okay, so kind of a follow-up question, how do, not everyone needs to respond, but if you have a response, what do you think about like your privacy usage, or is that not necessary?
Well, the nice thing is Anthropic offers you a sizable discount if you let them train on your tokens, but by default they don't at their TOS. Nor does OpenAI. Like they say that they don't, at least.
I didn't know about that, and I'm going to be honest, I've never thought about privacy with my code at all. Like, I'm just happy it works.
Yeah, unless you're working on like
Yeah.
government secrets, I see.
Exactly.
And then of course, if you're talking about the Chinese labs, because a lot of them have ways to interface with Claude Code, it really varies widely. You'll have to check the terms of service, like I think GLM, DeepSeek, they all have different ways of dealing with this. But generally, I don't think privacy is that much of a concern. Unless you're dealing with, again, secret government data.
I know you work for an organization too, Mike.
Yes, so although I work in an organization, but I think they also grant me access to these kind of agents, and I don't think they are very sort of protective of these stuff. But I do think that my version is probably a special version that has some sort of privacy, because I'm currently working for Meta, and this is actually some special version that is specialized for Meta. So I think it's kind of maybe they have some privacy protected, but I don't. Honestly, I don't really care, and I hope that I hope that either Anthropic or like OpenAI trains on my generations and
Yeah, I
interact
sometimes think that.
so that it can be better, and especially for me, it can learn what are my preferences or not.
Yeah.
So I don't really have these kind of secret working issues.
Yeah, no, it feels great to be incorporated into the pre-training
Yeah.
corpus.
I think I have a lot of history with my Claude code. Like it has a lot of training data from my conversation that it could use.
I think the
it's
big
helpful.
issue is that we don't have the level of personalization where it could be individually fine-tuned on your personal interactions yet. If anything, it would just be added to like some big soup of answers that have and interactions and your individuals, like you wouldn't get an individualized style. It might just make it better overall for all users. So I think there's definitely a lot of technical work, I think, on fine-tuning on local people's agent interactions that we have not yet explored. And I don't think we have the compute to do that, or at least the techniques to do that yet.
Okay, cool. Thank you all for sharing the demos and which coding agents you use. Okay, I want to ask, like, what mistakes have you seen using these coding agents?
Sure. Does anyone else want to go first?
You can go first.
All right. I'd say the issue with mistakes made by coding agents is that the kind of mistakes you see change because they get better very fast. Like, I'm not sure if you guys have seen the Meta time horizons, but basically there's there's a benchmark that measures on average the length of time that a coding agent could run and have a 50% chance of completing a task.
Nice.
So like a task that takes 30 minutes for a human to do, what's the chance that a given agent completes it? And generally this doubles every 6 months. And
What's the name of the metric?
METR time horizons.
METR time.
Yeah. Essentially, if you look at like Claude 3.5 Sonnet, which was like what we had a year ago, that had a time horizon off the top of my head of like 30, 40-ish minutes, and now it's up to roughly 2 hours. And this kind of gives a good intuition for the size of the task that an agent can handle without making too much of a mistake. Because if you look at the mistakes like early agents were making, like Nano GPT or GPT-4, they were really like it would lose track of files, it would lose track of context, and it would be unable to really track dependencies to multiple files. If you look at, and then there was kind of an era where the AI could write code that was really good in a few files, but it would have trouble integrating into existing code bases or like running code in a loop to debug it. It would struggle with that. And it would kind of, what would happen is the context would get poisoned by bad results and it would be unable to improve. And then I think the most recent generation of agents are very competent at running code, debugging code, and interacting with large code bases. The main mistakes I see aren't so much technical mistakes, like the agents don't make syntax errors or when they do, they debug that very easily. It's more conceptual errors where they'll spend a long time on a fool's errand or their environment doesn't let them do something. So rather than telling you, they go and try 10 other things or they create a bunch of files and run a bunch of things where GPT-5 often sets up a script, runs it, but the script takes 10 minutes to complete and then decides instead of making it run shorter, it'll just increase the timeout window on its environment and then run the script again and it will hang indefinitely. So I'm not at the point where I'm comfortable letting an agent run for like 2 hours on its own, but if you check in every 10 minutes, you can reasonably interface without too many like surface level mistakes.
I think what I think the agents are these agents are pretty good enough now that they don't make mistakes as long as you know what you're doing. I think that's the main important thing over here. Like if you give this tool to someone who has no knowledge of the language they're coding in or no knowledge of the problem that they're solving, it's going to make mistakes. And that's not because the agent is bad, it's because you're bad at giving instructions right now. It's like if you give good enough instructions, if you know exactly what problem you're solving and you in your head know how you're going to solve that problem or how you would have solved that problem if you were the one coding, the agent is not going to make mistakes. And even if it does.
Is there a long tail that they have trouble with?
I think it's
like suppose you ask it to write some code in a very obscure language.
Mm-hmm. I think it's because they make assumptions. I think that's the biggest problem. So if you give them a very obscure target, like just do this, like create this architecture for a transformer, and you give them a very, very vague goal, every intermediate step that goes within that like problem solving step, they're going to assume. They're not going to ask you. Like that's one of the biggest issue I have with coding agents. They assume a lot of information.
You have to be very, very
specific about what you have to use.
In other words, it'll just do something reasonable.
Yeah.
If you don't know it.
The most logical, I guess, or the most
sort of like
the meanest thing to do.
Exactly. It's sort of like view it as like a contractor or like an external someone who's very eager to do what they want to do and doesn't often check back with you unless you tell it to. And you were saying about the long tail, I think there's a benchmark called Aider Polyglot, which measures the ability to write code in different languages. And if you look at scores on that, it's gone from like 20 to 90%. So I don't think that obscure languages are as much of an issue. Like you're obviously going to do better in Python or JavaScript than you will in like Erlang or Haskell. But there's a guy I follow on X, Talon, who has his entire own obscure like HVM assembly thingy. Like he's basically working on a very obscure functional language that the models do not have pre-training exposure to, and modern frontier models can work with it and solve problems with it. And he
They
uses
do it by reading the documentation.
they're reading the documentation in context, and he uses them extensively to do work.
Yeah, I should note. So like I recently had to work with a language that I have zero knowledge about.
Oh, which one?
Stan. I don't know.
Stan?
Like it's a statistical. It's basically like I can share the link.
Was basically required for anyone doing grad school in the early 2010s.
Oh, is that?
Yeah.
Oh, I wasn't aware of
Yeah.
it. So
Yeah, did anything with like Monte Carlo.
Yeah, that's what I was using it.
Well, it's still the best software.
Yeah.
yeah, and so I had zero knowledge about it, and I think me and Tom they were working on it, and so we just use Claude Code to write the code, and I just explained to it what it needs to do in Stan, and it was able to do it within the first, I think, 1 or 2 tries, and I was able to get a working Stan script that still works pretty well. And I just had to go in and just verify that the logic was correct, and just by looking at the code at a high level. But everything else, Claude was able to manage and write the code perfectly for that. So
for me, I kind of have different stories. I think you guys talked about how competent these agents are, but I feel like sometimes the agents make very obvious mistakes. For example, if I instruct it to generate some sort of evaluation code, sometimes it's incorrect. Although it's not syntactically incorrect, but it does not do the thing that I wanted to do. For example, if I want to calculate, I guess as a specific example, I was calculating hazard k, but it does just generates k examples and do hazard k instead of like using more examples and bootstrap it, which is what I intended. I actually instructed to do more than k examples and bootstrap to generate the evaluation, but it didn't. It failed to do that. So it's actually doing some very obvious mistakes, and also sometimes it implements something correct, but still does not implement it in a way that I want it to be. As another example, I was trying to make a VLM inference like pipeline, and the agent did not like implement it. I wanted to implement as like with data parallel, with splits the data with multiple GPUs, and launch multiple VLM instances. It only runs one VLM instances, which is I think I instructed to do like data parallel, but it doesn't do it. So it's kind of I have this kind of mixed sort of experience with these agents, is that even if you specifically instruct it to behave in a way, sometimes fails you, and you need to like give it more instructions to do that. I think I'm still using like one of the most capable models.
Are you using extended thinking?
I don't think I'm using extend. I don't think I have a lot of extensive thinking in this.
yeah, I think those are only options present in like if you download
Yeah.
specific software like Claude Code or OpenAI.
No, it's
like options.
Yeah, but and GPT-5 Mini by default in the interface.
So I think what I'm using is Cloud Sonnet 4.5.
Yes, but if you're using that without extended thinking, it's important to distinguish, because for like complicated tasks that involve tensor manipulations or stuff like PAST-K or stuff that you'd really need to think about before writing, it's recommend if the AI can't think and you just ask it to output the code directly, it will likely output something likely, but it's not completely functional, that if it looked over again would be able to fix.
Yeah, let me double check. I think it still thinks for a while, but not very long. So I think I really prioritize getting the responses out very fast.
Yeah.
That I can look at it, debug, because I still need to run the code myself for model. So I'm working on a lot of RL problems right now. I don't think the agent is able to do these like very long sort of RL runs and debug it. So I need to run a lot of the code myself. That's why I don't like to wait for a very long time.
Well,
before getting out the response.
It's on the order of magnitude of like 2 to 3 minutes typically.
That's I think much longer than I expected, because for me I think it's much below 30 seconds.
Yeah, no, like sometimes when I give GPT-5 a problem in the codex harness, it will think for 7 or 8 minutes.
Oh.
And that noticeably improves the results. Like you can see graphs from OpenAI of like SWE bench, where they show that when you crank up the thinking effort from low to X high, you get like +8 or +9%. So there's a qualitative difference because I think it comes down to like most software engineering stuff is not very intellectually intensive. Like most of it's boilerplate and like echoes and sending things to places. And then if some of it is, and the models, if you use the approach where the model just generates the file in one shot, for in contexts where it would need to double back and think, especially like tensor manipulations, I find you run into issues.
I think this is just my experience on.
I should note that like what I try to do normally to prevent these kind of things is like I use this plan mode thing where what it does is like once I give it a task, it writes a MD file, a documentation file on what exactly it's going to do with some pseudocode so that I can verify that the logic is correct. Because that MD file is easy for me to read really quickly, and I can just check that MD file, and I can make edits in that MD file, which it can then go back and read and then implement the code.
Oh, that's clever.
That's like the way I do it, and I.
So the MD file has the instructions.
Yes.
And do you tell it every time that the instructions will be there?
Oh, so in Claude at least it has a very specific name for it. It's called
there's a
Claude.md.
special file that it
Yeah,
always
yeah,
uses for the instruction.
yeah. And I can
what
keep
is it?
editing. It's called Claude.md in my case. Like you can name it yourself, but I call it Claude.md.
Yeah.
So
You can also, of course, send it arbitrary
yeah,
files with
you can
descriptors.
link other files too.
Like often I just download a text, I brainstorm with ChatGPT in a chat, copy the specification it comes up with, and then tell Codex to implement it.
Yeah.
That is, of course, when I'm like doing fully autonomous stuff and feeling intellectually lazy, but you know.
I will
looks-
move on to another question, but
Sure.
are you demoing something or?
Yeah, I was just going to show like how the file looks like once it writes it. So this is how it looks. This was something I was doing, so it just writes like this really long document with like I think some links to some other papers and some methods. It's a really long document, but then what I can do is I can go in and read this document, make some edits over here, and ask it to refer back to it in case it needs to change its approach. And this is how I normally use this agent.
So this is an outline, this is Claude.md.
Yeah.
And this is a description of the whole project and
Yeah.
the architecture that you want
Yeah.
for the files.
Yeah, exactly.
And do you write that first and it evolves over time?
So I write like maybe 300, 400 words describing the project, and then it kind of does its own research, expands it a little bit, and makes like the version 1 of it.
Oh, it expands the file.
Yeah, it expands the file, and then I can go in and make more edits if I want to, and then it keeps track of this in every response so that it knows what it's doing. That's how I.
I see. So what stops it from replacing the whole file with write hello world, so to make things easier for itself?
Me. That's what I.
But if it's allowed to edit the file.
It can edit it technically to whatever it wants, but like I normally do
You
that.
got it.
Yeah.
In practice,
Does
it
it
doesn't
try?
try and do that.
I've never seen it.
The original model that was designed for Claude Code, Claude 3.7 Sonnet, loved doing things like that.
Yeah.
It would like do things where it would go and knock out all your unit tests to pass only.
Yes.
It does that a lot.
Nasty stuff like that. But
It would add
Anthropic-
try except clauses, and the accept would just be pass and continue.
Exactly. No, it loved making things pass and racking up a score, but Anthropic went in and they fixed a lot of that.
Yeah.
And modern models don't do that nearly as often.
I think you have a question.
Yeah, I was gonna ask, for some of these things, do you try to do something more like test driven development where you have it write tests to try and figure out like, especially like when you say no problems to
Yeah.
like, do you have it say, please generate a test and see if you can pass the test or anything like that, or just the empty files what you use?
I usually write the unit test myself.
Okay.
I don't have too much trust with these
Okay.
models, not as these.
Often what I do is I sanity check the data it produces. So I'll ask it to like compute summary statistics on the data or other analysis, and if that matches what I'm expecting, or I go in and read the text file myself.
I think I just have like my own trust measure, like based on how difficult the problem is. Like sometimes I know that the problem is hard enough that I need to go and look at the code myself completely. But for some tasks, like for example, one thing that I don't think in the last 6 months I've ever done is plotting. I don't think I've ever written matplotlib code in the past 6 months. That's all Claude.
A secret is I don't know how to write matplotlib because I was
I've
learning it when
forgotten it now,
ChatGPT
yeah.
came out.
Yeah, so like it's super good at that. Like it's amazing. Reading and writing files, for example, if you have a really complex JSON and you want to read some specific part of it, it's
great.
amazing at that. So these kind of things, I just do it without giving it a second thought.
Yeah, it's very good at doing these plots. Because,
Yeah.
like it not only gives you the plot if you wanna, okay, I wanna put this, I guess, legend fonts in a specific place, even if you enter this kind of like natural language instructions, you wanna make the plot prettier, you wanna make the plot colorblind friendly.
Yeah.
it also does it. I think it's like very, very good in these kind of product
And
scenarios.
another notable thing is that modern agents can read back the images they generate. So if they don't know how to do this on their own, I'm not sure why they don't have something in the system prompt for this, but if you are generating a plot and it looks ugly, you can say to Claude or whatever, hey, go generate the plot, look at it using your read image tool, and repeat that until you're satisfied. And that typically gets you better results.
Okay, cool.
All right, so I think we have a
Yeah.
new question.
Yeah, thank you so much. I really appreciate it. This feedback. So, the next question, so we've seen over the decades coding, like how we learn how to code has changed a lot from starting off with like writing code on paper to writing it on machines, to like the development of like IDEs to like being able to use tools to debug our code and yeah, something else. Oh yeah, with Git and then open source documentation, it just makes it so much easier for us to like learn and not have a lot of memorization being done. So now we have coding agents, and I want to ask you, the panelists, and also get feedback from the audience and particularly from the faculty here too as well. How do you see our learning? So we have people from like all different years, from undergrad, master's, and PhD. How do you see like learning in computer science to shift with the introduction of coding agents? And this is open to panelists, and yeah, I'm particularly also interested in what the faculty have to say.
All right, I typically start. So again, do either of you guys want to start?
I think, I mean, I guess something to note was like something that you said before was like not being able to write with like matplotlib because
Yeah.
so I guess can you explain maybe like your
Okay, so
Yeah,
my
let me-
perspective. Sorry, go ahead.
Sorry. Yeah, I'll address that. The reason I don't take the time to learn matplotlib is because I'm not looking to make any breakthroughs in matplotlib. For me, I just need a machine that generates a graph, and I don't particularly care how it does it. I think it's important. I think one of the reasons memorizing and understanding things and knowing how to write a certain kind of code is important is if you want to make some sort of modification or innovation to that, because it helps you have a very abstract understanding of what's going on. Like, for instance, the concept of a derivative. Imagine if every time you heard it, you had to go back and read the limit definition, calc 1. That would be absolutely brutal. The reason you memorize the concept of a derivative and understand it is because you want to be able to use it and apply it in ways beyond just taking a derivative. You want to be able to apply it in higher math. You want to use it as kind of a reusable tool that you deeply understand. But I'm not really looking to do that with matplotlib. All I need is a tool that takes in data and makes graphs. If I was working, for instance, with cutting-edge graphing technology and the raster algorithms used, I would probably go and analyze the source code of matplotlib and learn a lot more about it. For me, it's about what I'm trying to do innovation in versus what I'm trying to just use as a black box. And like, for instance, with the transformer models I work with, I go and I read the model implementations and I work with them myself. I don't just treat them as a black box because I actually want to make innovations with them. But I don't think there's much harm in taking something you never really would have needed anyway, and you wouldn't have intended to innovate on anyway, and locking it away in a black box.
At least if it's kind of a standard.
Exactly, if it's a standard
Standard use that the model is likely to get right.
Exactly, much like in the same way we lock tons of assembly in boxes when we use garbage collectors and object allocation, all the other main features of high-level languages.
I think like my perspective might be a little bit different. I learned to code before I learned to use AI agents. So like for me at least.
So did I.
No, I mean like in the sense that I did a lot of coding of all of the things that I use agents for now, like Matplotlib and all that for 2 years. And I think that it still should be something that people should do. I still feel that if you know how to write the code that the tool is writing for you, you become a better debugger in general of that code. And I think that helps me solve a lot of the problems that I run into with coding these coding agents is because I can kind of see the problem that they are going to run into before they run into that problem, because I know that when I give it to solve this task, I kind of know that that's where the problem is going to happen. Because if I were to code that, that's where I would probably look up documentation, for example. And so the fact that I know that that's something like that would happen makes me a little bit more like used to spotting those errors before they happen and like tackling them. Because I know for a fact that if I didn't know if I didn't know the transformers library, for example, if I didn't know Hugging Face or if I didn't know PyTorch, 100% I would be running into more issues every time I used Claude Code. So knowing all of that stuff does help you. Even with Matplotlib, it's amazing at plotting, but like things like sometimes what it does is you want the lines to be a little like you know the legend, and the legend sometimes overlaps with the line, and you want the
Or you have to
legend
move it around
yeah,
manually.
yeah.
It's not good at
And
reading.
then you're like, okay, but Cloud Code is not able to move that around to a place where there's no lines so that it doesn't overlap. So for that, I know that I can go in and actually change the legend position, but Cloud Code doesn't know that in the first or second try. So I kind of like just prompted beforehand to do it because I know that's going to happen.
And
That's
like maybe one reason to read the documentation is so you know what's possible.
yes, yeah.
Like you wouldn't ask Claude Code to do it if
Exactly.
you didn't think that the.
I already know that you can move it around, so I just did it beforehand. So I think that helps if you already know the libraries you're working with.
I think that makes a lot of sense. Yeah. Tianjin?
I'm sorry, what was the original question?
Yeah, I guess the original question was like, how do you see like learning in computer science to change?
My understanding is that coding is a relatively small portion of learning in computer science. I think being able to know how things work is the most important part. And when I was in undergrad, I learned a lot of assembly code, C++. And right now, I know like really nothing about these assembly code and how like the lower level things, because we have these like very good abstractions that is like handling all the things for us.
Yeah.
And I envision that in the future that we have like even higher, more intelligent versions of abstractions. So I think that the coding part is actually like not really that what you want, but still I feel like you need to be able to learn how things work. I think this is the important part.
Can I ask a question?
Yeah.
Or have you guys all had a chance to answer first?
I have one other thing I want to add, but I want to hear your question first.
Okay, yeah, so I'm wondering if it should change the order in which we do things. So right now, you use compilers before you learn how they work.
Yeah.
Yeah.
You know, you probably start with interpreters actually, and you know, maybe you're writing a program that does turtle graphics, and this is before you've learned anything about graphics. And then later, more advanced courses, you learn what's going on inside. And that's the opposite of the way that we teach basic programming, where you start by declaring variables and making loops and things like that, and you build up into bigger and bigger. And so I wonder if people will start doing more of the top down for basic programming, where people, you know, first year students are starting with application design, and then later they're learning how to code.
I think you're
I don't know if this is a good idea or not.
I think you're wholly correct.
Yeah, I think the top-down approach is going to be more interesting. At least when I was an undergrad, I would hope that I would start from application instead of trying to learn these like very low level.
But do you think that's a good idea though? Like that's what
I
I'm not
don't
sure.
know.
I'm not sure.
I just think from historical precedent, like I think your example of compilers is a really great one. Like well, of course, there's like provability with compilers and knowledge that they're more reliable than non-deterministic AI agents. But the question is, eventually, these abstractions will get good enough and capable enough that the average person making an application isn't going to have to interface with what's below them. Like just in the same way that someone who's writing a really performant video game engine might have to work with C or assembly today. Well, not assembly, sometimes assembly, but most people who are developing applications just need JavaScript. In the future, most people who are developing applications just might need vibe coding.
Yeah, I think I agree with that.
Especially because these things are getting so much smarter. We also don't know how much smarter they're going to get.
Yeah.
Because a lot of it depends, do they stay like this after a year? Is there kind of a quote unquote a wall in which they get a little better, but they never really reach the level? Or do they get better than human software developers and kind of like, because right now I'd say I trust GPT-5 over me on tasks that are probably 10 to 30 minutes long. Like, I trust its knowledge and its ability on a task roughly of that length. I do not trust it on a month-long task where I like investigate a long study and write a paper about it. But if you extrapolate in 5 years, we might be at the point where we do. So we have to think about what learning would even look like in such an environment.
I think that like being able to train a good software engineer and being able to like the computer science education is a different thing. And I think that the software engineering part is actually like a very narrow part of at least what we're teaching at school. And I think that
maybe there's a question I should ask Jason. What's the point of teaching people how to code? What are we trying to do?
You know, I have a possible answer. I've been talking a lot, so I'll let you go first.
In other words, what is the point of teaching people how to code? What are we going to get them to learn from?
But while I was teaching computer system fundamentals, I really liked it because it really explains how things work out in the hardware.
Okay, good.
And I think that's still.
So that is still true.
You don't understand what code actually does, what capabilities are quite slow, sometimes quite fast. if you only have a very abstract view, sure, you run something like, why does it take 10 minutes? No one can.
Okay, good.
I-
So in other words,
You have a better
you want-
understanding.
the point of teaching people how to code is that there's an abstraction at which people will function.
Yeah.
But you need to know one or two levels below it, what's actually going on, because that affects how you use the abstraction. Because I could then argue, why don't we teach them assembly? Because they can use the code in assembly.
Why not teach the physics of how the electrons move in the chip? I'm just saying.
You're tackling with
I can tell you how a PN junction works.
I certainly could not. But yeah, no, I'm saying there is actually, I think, a legitimate. I think it's totally legitimate. There is a legitimate argument to say, hey, we should start with the electrons and then go all the way up to where we are now. But I think ultimately the people at that point, the theoretical objective of truly understanding how a computer works becomes divorced from like doing software engineering, much in the same way that there's like a ton of benefit to studying mathematics that you like. I enjoy studying mathematics for the sake of mathematics. And I enjoy, like, say, writing an essay, even if ChatGPT could, like, write a better one. And I study and do those things in order to get better at them because I enjoy knowing how to do them. So I think there's something to be said of, hey, there's just part of learning to code. It's just learning and understanding this because it's beautiful and it's interesting and it's intellectually stimulating. And I think that can sort of be divorced from the functional, how do you learn to software engineer? Much in the same way that the invention of the calculator did not suddenly preclude people from learning all sorts of from learning how to do rote arithmetic.
So I don't disagree with any of the answers so far, but go ahead.
Why do you teach people how to write also? Like,
Yeah,
that's the one I would think.
Because it's fun.
Right?
Yeah, just right now.
Plain writing.
Yeah, like writing natural language, right? It's a similar sort of thing. It's this skill and a tool to get something done in a lot of ways, right? Like I was a CS major in undergrad, and I did not have to program my junior year. I took lots of CS classes, but there's a lot of theoretical stuff there also. So to Tangent's point, there's a lot more to CS than there is. Now, there's parts of software engineering. And I remember now, a couple decades ago, basically, where people were like, non-CS majors are like, oh, well, I keep hearing that in 2 years all the technology will change. And everything you've learned is obsolete. I'm like, well, that's why you don't learn the latest thing about, like, I don't know, Python 1 point whatever, right? Like, it was more about like, okay, how do you learn to think about the problems and stuff? And I think that's not changing with these tools. It is a high level abstraction, but you can still learn the lower stuff.
I think what's qualitatively changing is that now the tools can think about the problems. Like, what's ultimately different is, I think, from all other prior technology operated at a level of abstraction, but ultimately was predictable and deterministic and didn't really have the ability to think about problems in the way a human would. And while you can debate how much these like machines think or whatever, it remains to be said that these machines can solve, specifically large language models in their modern agentic forms, can solve problems out of a far higher scope and scale. And I think that does meaningfully redefine a little bit of just thinking of these things as machines.
I might have a different perspective on that. So I know they can solve really complex problems, but I don't think that they are still capable enough to solve problems that a human would be able to. Like, there's a categorization of problems. For example, Claude Code can build a website and an app, and we had to do this for a class of ours. So, like, the class requires us to design an ML systems. It's the ML systems class with Professor Dresser, and you have to design like a startup kind of thing where you have some app that does something for social good, which uses machine learning somewhere. And the entire application, which was an iPhone app and which was, I think, what is it, Swift? Is used for iOS. I didn't even know that. So, I mean, I don't know.
It's a successor to Objective-C.
I like zero knowledge about that, but that and it used React.js and all that stuff, and it made the website and the app, which is really cool. But that is a complex problem that agents can solve, but can it do research? Like, can it actually think of if I come up with a problem statement that I want to solve it, can it come up with a novel solution to that problem? I don't think so. At least I haven't come across, like, in my conversations, a situation
People are trying to come up with worthless fruits.
Yeah, I mean, people could.
Within 5 years, maybe the answer.
Yes,
well,
maybe.
I think we have to extrapolate here. Like, Claude Code can build that app, but GPT-4 could not. And
yeah, I mean,
I think it's a mistake to categorically say there's some problems that are just like rote things that machines can do, and then there's some problems that are research things that humans can do. Because if you look at what's happening is, Terence Tao said that GPT-5 is one of the first systems that he's felt comfortable collaborating with on small mathematical problems. He said, obviously, it's not professional human mathematicians level, but it's good enough to do basic graduate level research. And there's a whole compilation of reports of this. And what I'm saying is, I think as these machines scale up, what we're going to keep finding is that things that we thought were human problems only are increasingly also machine problems. Because like all the stuff that Claude's code is doing for us today was distinctly human only. Like you might use GPT-4 to write a snippet of code here or there, but it could never make a full iPhone app.
Yeah.
Obviously, it could never do novel research, and we should consider where these things are going until we see clear evidence that they've stopped going, and we haven't seen that.
I think that I mean, like in 5 years, I'm not sure.
So I think when we
Maybe I
talk,
wouldn't have.
I think when we talk about teaching CS, we need to consider where things are going as well, because if things are rapidly changing. Actually, I might change my position mid-argument here, because if things are so rapidly changing, as you were pointing out about those frameworks, and a big issue is if things are rapidly changing, teaching to what exists right now might be missing the forest for the trees, and it might make more sense to focus on, as you were saying, the fundamentals until this technology becomes stable, and then you could integrate it into the curriculum. So I'm actually genuinely unsure after this discussion.
Do you have more questions? Maybe we can move
Yeah.
on.
I guess the only other question I had was on productivity, but I'm also happy to open it up for anyone that has.
Oh, but you had a study, right?
Sorry.
There's a study that.
Oh, I mean, I was just saying there are general studies on this topic that kind of give varying perspectives on how coding agents improve productivity. I wasn't gonna cite one in particular, but so I just kind of. I guess, yeah, if you guys have any perspectives on that, but we kind of have some answers to it, I guess, but the questions more pertinent are.
Yeah.
So there are multiple questions.
All right, let's take questions.
So I have just a practical question that might be on other people's minds also, which is when you start a new project, what is the workflow like? Like Prabhu showed a repo that already had lots of stuff in it and said make an edit. I want to know if like on day one I have a new project, how do I start? Where do the unit tests come from? Do I have any control over like what the class design is? Which parts of the code should I write before asking it to do things? Can you give some?
So I think I can talk about it because I recently started working on a new project, so something else. But so how I normally do it, and this can obviously change depending on who's doing it and how they want to do it. But how I normally do it is when I start a new project, I will first write the Claude MD documentation is the first draft of that is what I write. So I completely go ahead and write all of that. I do have some docs that I always use. So I have some principles that are not principles, but some things that I like to keep in my code. So how I do comments and how I name variables and how I design classes. There's like one file in which I've written all of this stuff, and that's how I like to do it. So I always reuse that across my projects. So I have like these 2-3 files about how I code, what variable name should I use, what class design should I use.
Could you just give it some sample of your old code and say follow that stuff?
You could exactly, yeah. But I normally just put this in a doc, which is easier. Like they read MD files really well, and I think there's some reports that like if you have your prompts in the MD5 format, it works better with these agents because they are trained on a large scale using.
Okay, but you could take your past code and say write an MD file that describes the style.
So that's how normally I start it, and then what I normally do is I don't just start with coding. I have like at least 6-7 cycles of discussions in which I'm just talking about the work and like looking up some research papers. Like if you saw that documentation I was sharing had like 5-6 papers in it also. That's because I asked it to look up like related work and then link back to the repositories of those related work so it can go through the code of those papers, kind of understand how this kind of specific field works like and how.
And at every step in the conversation, you say, okay, that sounds good. Put it in the Claude.md.
Yeah, so it's like me, I'm editing some stuff and Claude is editing some stuff and it's putting in more stuff and I'm reviewing it and changing it. So that's like about 2-3 hours of discussion.
Okay, so you're co-editing the Claude.md.
Yeah. And after about when I'm like kind of certain that I'm at a point where I can start coding, then the first thing is like I just like tell it to just start writing the first requirements file and stuff like that, and just some basic code that I can start reviewing. Normally I don't write.
Ask it to write one file at a time.
I normally I go 1 or 2 files max at a time. I know there are people who also do the entire project at one time, but I like to go 1 or 2 files at a time so that I can just like kind of keep track of it.
Yeah,
that's how I do it.
I wanna quickly because we're almost like out of time.
Oh, sorry.
If we can either.
We have till 1:15 actually.
Okay. I just want to see how many more questions there are because I want to make sure we have time for all questions. But we can also circle back or.
I do want to quickly. Sorry, we should go on to the next questions. Yes. So raise your hand if you also have a question.
I guess Philip had a question.
I had basically the same question, like how big of a chunks do you give it to
Sure. Yeah, good.
Yeah, I think it depends on.
Yeah, I think it varies
One file at a time.
very heavily, but personally, I'm more about tasks than chunks because I do a lot of experiments, just data analysis, running things and such. I typically will give it a task that I think is moderately fast and tell it to create, delete, like create, modify, or run whatever files it chooses. And that one conceptual thing like, hey, I have this JSON file. I need you to compare 4 different ways of regressing something and then tell me which one is best.
Yeah.
And then I'll let it go and do whatever it wants. Typically, ChatGPT's codex also can run Python on its own temporarily. It doesn't need to make a file for that. And often at times it will not make a file. And if I want explicitly a file to inspect what it did, I'll tell it where to dump it. But typically I think more in like units of tasks than units of files. But that's also because I don't typically build giant code bases.
Me too. I just operate on simple tasks. I just give it the instruction, okay, please write me a script on run these evals, and they will just write the script for me. Yes, I think what I use is much more simple than what these guys use. Is that I just use these very little tinkering of the code with AI, and most of the code I do I do modify it myself.
I normally start with the hardest problem first. So, like for example, if I'm in this case, I was doing something with a new architecture for some transformer basis thing. So I tell you to normally write the architecture file first because that's the hardest thing to do. And so then I can go in and edit and like ensure that that is perfectly fine before I go on to the easy files like the main.py with some art parts in it. Those are simple tasks. Like I know that it can do it pretty well. So I normally just get the hard thing out the way first, and then I can write the easy files.
Sometimes I start with the stuff that's easy for me but hard for it. Like for instance, the MLX framework is very new. I use it a lot because it's training on Apple Silicon, and GPT-5 does not know it. And if I ask it to write stuff in MLX, it goes on documentation hunts and it takes it much longer. However, if I take 10 minutes to write the initial file in MLX demonstrating a training loop, how I want it to be used in the project, and a few things, it's suddenly able to use it far easier, and it can tackle far harder tasks in MLX than if I did not give it that initial file that primed it on how I wanted to use MLX in the project. All right, so yeah, is there next question? Let's see.
So I wanted to make a comment to you guys, and it was evident in everything you were saying, but I was going to point it out. A year and a half ago, I was at a conference where a guy from planning and award things gave a plenary talk about LLMs. And he pointed out something very interesting. He said that the analogy he gave is there are a number of very hard problems in planning. Hard in the sense that finding an optimal plan to do something is computationally hard, and hard in other ways, and so on and so forth, even if computation is hard to characterize. But then he said a pretty standard paradigm is that you have a plan proposer and a plan evaluator. And there's actual stuff they do. And the evaluator is very good at checking if a plan is optimal or near optimal, but it's not good at figuring out or suggesting plans. And so the idea there is if you can build a good hypothesis generator and a provable hypothesis tester, then as a team, they work extremely well and you can solve some fairly hard planning problems. And what almost everybody who uses LLMs but refuses to recognize is that they are the evaluators. That the LLM does all kinds of stuff and it can be all kinds of good and crap. And if you weren't there, it would do nothing. It wouldn't come up with any useful code. And the point of this is that to think that if you don't know how to code, it's okay, and LLM help you is totally false. It's only as good as you are.
I agree.
It can propose good architectures, good like architecture, software architecture, good pieces of code, good this, good that. But if you aren't there to evaluate it, it's not going to work.
Exactly.
And as a result, to anybody out there who thinks that they can not learn how to code because LLMs are there, I would say think again.
I think
that's my comment.
I'd like to respond. I think that's most.
I need to leave in a minute, so if I leave before you finish, it's not because of your answer, but go ahead.
No, don't worry about it. I just wanted to quickly say I think that's mostly right for current LLMs, but we have examples. Closed form without supervision on like ICPC or did I say that right? Is that the right acronym? Probably. Yeah, International Programming. Yeah, thanks. Yeah, that. They can solve those problems without human supervision, and they will return a correct answer and on their own. And I think the fact that they can do that, those are closed problems with verifiable answers that are pretty easy to solve, indicates that they can clearly generate some level of code without a human manually checking it. I think you can take an LLM a lot farther if you know how to check its outputs and you know how the coding works. You could probably move it, quote unquote, time horizon out far more than it could do on its own. But I think it's inaccurate to say that they can do nothing on their own. I know people who do not know how to code who have used LLMs to do smaller tasks like quick analysis or quickly mocking up a website and have seen great success because the tasks they were having it do were not that complex.
People also use LLMs as evaluators a lot, so they might be able to.
Yeah, LLMs can evaluate their own work half decently.
Debate. I have to
That
leave
are
because I
proposing
have
and
one
evaluating.
Yeah,
As an analogy, you don't need to understand combustion engines in order to drive a car.
exactly. Like you can check if the website looks good by looking at it. You don't need to know how HTML works. I know that's a low standard, but still. Is there any other questions? I saw a question up there at some point.
I was saying, it's big now.
Come down here.
All right, so
No, we're at.
yeah, all right, yeah, all right then.
Any remaining questions?
Oh, awesome.
I'm wondering, I think you guys have been speaking about these agents very much as black boxes. I'm wondering if there's anything you think about the processes of what they're actually doing. Like, I think in particular what's interesting to me is like sub-agent orchestration, like, or any other like tricks or stuff you guys do to actually make the agents like work. I mean, because like in Cloud Code you're able to do customization, right? Like, I don't know. I'm curious about stuff you actually.
Here's what I like to do. I like to see the thinking traces. I think there's more information in thinking traces than the answer that Cloud Code gives me. So if you do for this, it's commando. But if you do commando, you can see what it's thinking in real time before it outputs the answer. And I sometimes don't even see what the answer it outputs. I just look at the thinking traces. And the thinking traces has more information for me than the actual answer. I can actually see how it arrived at the solution before, like, instead of looking at the solution. And that helps me more in deciding what next steps I want.
Yeah. I think, yeah, I generally agree with that. Look at the thinking choices. I'm skeptical of sub-agents. I think that you typically can get a lot out of just one main agent, and that if there's too many people working at once, they can all interfere with each other. But I haven't used them enough, and I'm sure someone who's very competent with them could use them to great effect. So, and I think finally your comment on the black box, we treat them kind of like black boxes because these are like harnesses built by people who very much know what they are doing, and often trying to go outside the harness or interact with the model on your own or do it yourself is you're not going to have as much information about how the best way to use the model is compared to the people who train the model. Oh, maybe you do. Back in the day, I think people could build harnesses better than OpenAI's much easier because like GPT-4 was not built to be an agent, but the new OpenAI models are trained using OpenAI's harnesses and they're trained to use the codex prompt format. And it's all essentially done in-house, and that makes it very hard to beat. And that's kind of treat it as a black box because that's the best way to get a performance out of it, not because you're scared of opening what's in the box or it's like spooky or whatever. Yeah.
Kind of just like a practical question. Something I don't really see is how to even use these in my workflows. Like, for example, like boilerplate is something I basically never write. It's like boilerplate, like why are you writing this over and over again? And then in terms of like the things that I'm writing code that is taking all of my time, it's usually tasks that like to explain it is even longer than to just write the code myself. Like for example, if I'm trying to implement some math that I worked out by hand, like it's just a few lines of code. And like I don't even know how to explain that to like to the agent to like do this thing. And it's not something that, you know, if it's research, it's new mathematics that like, if I don't have a name, it doesn't have something I could like refer it to. And so that's kind of like the gap that I don't really get is like, what is it? What are you actually using it for? Like, what are the things that had to be done by you before, but can be done by the LLM?
For me, it's typically, other than boilerplate, I'd say writing training code, writing statistical analysis code, just executing well-known things on novel data sets, essentially, or trying out experiments that I know how to run. Again, essentially, for most of this, the time it takes to write out the code is longer than the time it takes to explain what I need the code to do, especially because the code might implement an algorithm that just has a lot of numpty boilerplate, or it doesn't have a neat singular neat function and requires like, you know, multiple for loops and multiple for loops, that sounds ridiculous, but you know what I mean. Like it requires multiple iterations or passes, but the code is fairly obvious once you hear the algorithm. And
yes, so like to kind of push on that,
yeah.
like, when I'm doing an experiment, like I download somebody else's code because it has a training loop, has the evaluation plane. It's like I think of GitHub as basically being endless, like,
Yeah, I typically just write it myself using an agent.
but why not use the like publicly available code that you?
Because it's often using a specific Hugging Face data set that isn't used anywhere publicly, or like something that no one has tried before.
Yeah,
I'm
don't
just-
have this experience. It's like, particularly like a publishing point of view, if you can take somebody's existing code with existing numbers on an existing benchmark and like directly compare it with set. So that's what I'm like always like trying to.
Yeah, I think this is what I use as I can actually resonate with that because I also download GitHub code and I just try to make my own modifications on top of that. When I'm making the modifications, I sometimes use these edit mode of certain agents so that as a more specific example, I was using a RL code base called Virl, and I need to modify some of the logic inside it. So I just use the edit mode of the Copilot to say, okay, please help me modify this rollup generation logic so that it customized for my specific task. This is what I use. So
Especially some of the big code bases, which have like thousands of files across it, and I really need to find something very, very specific in there that I need to change. That's where it helps me because I can just connect that entire repository to my agent and say, look for this.
So this makes a lot of sense, but then the fear that I always have is, how do you know it's correct?
You gotta check it. That's
I don't understand.
yeah.
So it's like, I remember I was working with like SpeechBrain last year, and it's like, I thought I had changed something, and I had not, because the code was developed very poorly, and somebody had hacked an implementation where like data augmentation was happening in 2 places. And I thought I understood the code, I did not, I changed it in 1 place, and the other one was not changed, and like all of my experiments were like kind of junk. And, clearly I can make that mistake too.
Yeah.
But I don't trust the LLM to not make that mistake as well.
It seems like you need more robust testing in order to be confident using this stuff.
Yeah.
You need to run it yourself, basically. This is what I use is that after the LM makes a modification, every time it makes a modification, I run it myself to see if it like matches my expectation.
Yeah.
If not, I would need to manually redo the asking the LM again to do the modification for me. So yeah, this is sadly we need to check it myself.
Yeah, from what I understand, I think you guys do a lot more of when I'm doing projects that are typically smaller, and it makes more sense to like ask the LLMs to build whole files that I'll never use again. But I think you're totally making a very good point that like for these large production code bases where it comes down to making a few tweaks that it might be easier to just do yourself, these agents might not have as good of a use when it's faster to change the code yourself than it is to explain what you want to do to the agent.
Honestly, it has been a very long time since I've written the code base myself. I always used like existing code bases, like for example, download someone else or existing code bases for pretty much all my research projects.
Yeah, like that was to some extent, like
I thought something basically.
To some extent, my question comes from like what I see is the big jump in my productivity from when I was a student. Like I started off by like, okay, here's this paper, I'm gonna implement it myself and test it and all of that. And it's like, that was a waste of time. And I think if I had an LLM, I would say, oh, I can just have the LLM do it. But I just, that didn't exist when I was a student. I jumped right ahead to saying like, what you should do is like, the most valuable skill was finding somebody else that has done almost everything you needed to do.
I think I have faced that because I was looking for some paper, like if you find a repository of the paper that someone has implemented, that's pretty good. But I tend to find myself more in cases where the paper is there, but there's no repository.
Or the repository is horribly organized.
Yeah, and in that case, as an LLM, I have actually used Claude to just read the paper and implement the code or write the complete code for that paper and reproduce the results from scratch.
How well does that work?
It worked I've done it 2 times. So I did it for batch, which is I forget it's some gradient alignment technique that we were comparing the method and annotation arena that we were doing to, and I wanted it to implement that entire paper, and it was able to implement and reproduce the results what were said in the paper. But that's because the paper was very well written.
Yeah, I also think that's like a very interesting use case for me because also when I'm implementing, it's like papers frequently leave out a lot of details.
Yeah.
And you don't know where those details come from. It's like domain knowledge.
Yeah.
And I do see like this, the reasonable assumption of the LLM
might be the correct thing to do. Yeah.
The stack, the technical stack of training LLM is really high. For example, you need to know a lot about I guess, tensor operations and distributed training.
Well, you
And
mean
you
like
really want to implement the code yourself about all these handle all these things yourself. And for example, if you want to train an LM right now, you need to use flash attention, but it's kind of impossible to implement that yourself, and you can just integrate it into yourself. So I don't think that currently it's a good thing to like implement things from scratch, especially if you want to. Okay, I have many GPUs and I want to train like a large model.
yeah, I think doing stuff from scratch with LLMs, like making toy scripts, like a lot of what I do is on smaller scale models. So if you're only using one GPU, I can see that, but it makes like ton of sense. Distributed RL is a nightmare, and using someone else's framework and modifying that makes a ton of sense.
But I also want to know, like, we're not implementing from scratch, if we're importing it from a library, then like.
Okay, that's not what I more mean is writing the exact like training script yourself instead of using someone else's.
But I'm talking about like flash attention. We're not
Yeah.
implementing flash attention from scratch. We're
Reading the
importing it from somewhere. And if we do have to write it from scratch, like the LLM can't do it either, because it has to have learned it from somewhere. And if
Yeah.
it's learning it from somewhere, then someone else has done it, and if it's made enough training data, then people are doing enough that they then write a library to do that stuff.
Yeah. Yeah, you can kind of there's a view of an LLM as kind of a library of Babel of all the code on the internet that you can kind of reach into and get whatever function you need. But it's some of the books are copied wrong. Yeah.
So before people leave, someone asked before how this got put together. And I will tell you, it's because another faculty member asked me if I had observed something that they were seeing with their students. Namely, they had two kinds of students, the ones who were using LLMs to code and the ones who weren't.
Which
the ones who were
faculty?
using LLMs to code were much more productive. And I said, maybe we should have a panel about this. So I sent a note to Yulu, who very kindly managed to organize this whole thing. So she's left, but
Awesome. Thank you so much.
thanks to all of you.
Hope it's helpful.
Yeah, no,
Thank you.
I was honored to be here. Thanks so much.
Thank you very much for coming. This is great. I'm still not sure like which thing to start with.
I'd honestly recommend if just to get started.
Use it, download.
Yeah, download Claude Code, download Codex, and then do you know like how to do front-end web development?
I mean, there's a lot of things that I could.
Yeah, exactly. Like choose something that you aren't super familiar with. You have a gist of how it works, and then see how far you can get with and how fast you can get with like Claude Code. And generally, I think front-end web dev is a great example because most people don't do a ton of front-end web dev, and it's not too complex to like go and debug the code yourself. But you can also get very far very
And
fast.
you're recommending Claude Code and Codex.
I would say Claude Code, yeah.
Suggesting GitHub Copilot.
Are you subscribed to ChatGPT or are you subscribed to Claude?
Copilot is easier, I would say.
Copilot has access to all of them. That's one benefit.
But
yeah.
yes, but Copilot has overall less users and less agents. I would strongly recommend starting with Codex or Claude Code. But then again, I think that's not a settled debate.
Thank you so much, everyone.
Of course, yeah.
Thank you. I'd say a fun way to do it would be just give it one of your papers, the ones that you have written.
Yeah, I can try to replicate
And tell it to replicate it. I think
Not a problem.
Yeah.